Alright guys, today we're going to look at the process of factoring polynomials. Now, before we jump into this, we're just going to look at a couple of different methods and tools that you can use when you're factoring. There are a lot of different things to take into consideration to kind of decide how you're going to factor things. Basically, the idea of factoring behind factoring polynomials is you're breaking it down into things that can multiply to equal that polynomial. And I'm going to look at a couple different ways of doing that. So I'm going to start off here with an example. I've got x squared plus 7x plus 6, which is a trinomial, and I want to factor that down into parts that can be multiplied to equal this polynomial. That's useful for solving, for finding zeros, all these kinds of different things you can do with it. In this case, we're going to use what you'll hear some people call the reverse FOIL method, and I'm going to factor it down into two binomials. In doing that, and the reason I'm choosing to do that with this trinomial is it doesn't have any greatest common factors I can factor out, but it is a trinomial that we can break down and factor into two binomials. And so to set that up, I'm going to just create my parentheses here, which is where I'm going to fill in my two binomials. And then if you're familiar with the FOIL method, it's a process of multiplying two binomials to get a trinomial. It uses the acronym first, outside, inside, and last. And so basically I'm going to think about each of these steps and then go down the row and fill in what I can. So my firsts, that's the first value of each polynomial, which would be here and here. And if you multiply those together, when you're doing the FOIL method, you're going to get the first value in this trinomial, which is x squared. So thinking of things that multiply to equal x squared, the only logical explanation was that both of those would be x, because x times x is x squared. And so that covers our firsts when we're thinking about that FOIL method. And the outsides refer to this position and this position. We can't really do anything with that. We're not entirely sure what that second value is. Same thing with inside. It kind of goes, it's right here and here, but we run into the problem once again of not having enough information. So we go to this last values. Now the last that's referring to is here and here, which we don't know either of those, but what we do know is that they should multiply to equal 6, which is your constant in this trinomial, and they should add or subtract to equal 7. And so because of that, because we have that information, we start thinking about multiples of 6, things that are factors of 6. 6 times 1, 2 times 3. You see that 6 times 1 is going to be what you want to use, because it not only multiplies to equal 6, but it adds up to equal 7, which is that coefficient. And so we put that in. Both are positive, because it's a positive 6 and a positive 7 that these are adding up to. And so this is our factored version of this polynomial, x plus 1 times x plus 6. And here's the other thing with that. You can actually check that information and make sure that it's right by actually foiling and multiplying these back out. And so you go x times x is x squared, x times 6 is 6x, 1 times x is x, and 1 times 6 is 6. And then when you combine your like terms, what you're looking for is, hey, is when I multiply this back out, does it match what I originally started with? And it does, so you know that this is the correct way to do that. So that's the reverse FOIL method, basically used for factoring trinomials into two binomials. And the other example I want to look at here is factoring a polynomial by factoring out the greatest common factor. Anytime there is a greatest common factor to factor out, you should do it. That should kind of be where you start. And so looking at this polynomial, I've got 2x to the 4th plus 5x to the 5th plus x to the 10th. What I'm looking for are values that will multiply to equal all of these, or multiply into all of these values. And so I start by looking at my coefficients, 2, 4, and 1. There are no numbers other than 1 that will multiply into all those. So then I move to my variables. I've got x to the 4th, x to the 5th, and x to the 10th, and I can actually factor out an x to the 4th for my greatest common factor there. It will multiply to all three of those. And so then I'm looking here when I begin to fill in my parentheses, and I'm going to say x to the 4th times whatever goes here is equal to 2x to the 4th. Well, the answer there is 2. Okay, so 2x to the 4th. I call the last method the reverse FOIL method. You could almost call this the reverse distributive method because you're basically undoing a distribution that's taken place. And so then you move on, x to the 4th times what equals 4x to the 5th, and that gives you 4x, and then x to the 4th times what equals x to the 10th. Well, that's x to the 6th. And so this would be your factored version of this polynomial by factoring out what's called the greatest common factor. And so these are a couple of tools you can use for factoring polynomials, kind of get you going on those. Good luck.